Hello everybody, this is Mr. Mahmoud Najm and here we are to understand physics. What are we going to learn today? Today we are going to learn about Kirchhoff's rules. And the topics in the presentation would be why to use Kirchhoff's rules, and then we're going to learn about Kirchhoff's rules of junction, and then Kirchhoff's rules of loop, and finally we're going to solve an example to understand how things work together. But why do we need to learn Kirchhoff's rules? Basically, Kirchhoff's rules are used so that you can solve problems in electric circuit when the circuit has more than one battery. Ohm's law cannot handle such circuits. So if you have 2 batteries or 3 batteries in the same circuit, the only law that works properly for those circuits would be Kirchhoff's rule. The first one of those rules is rule of junction. What is the rule of junction? Rule of junction basically is the rule that shows how the current flows through the circuit. So if you look at the circuits in here, we label the circuit, and it's a normal practice for solving problems, as A, B, C, D, E, F. As you can see, point B and point E, they have a special condition, because at those 2 points, the current has more than one option to go through. For example, if the current comes from the side C, reaching side B, at that point of B, it has an option to go through point A or E. And the same at point E. If the current comes from side F, once it reaches E, it can go through B or D. But such option is not available at A or F or C or D. So when the current has more than one option to go through, we call this a junction. So what is the rule of junction? According to Kirchhoff's junction rule, the summation of the current entering a junction must equal to the summation of the current exiting a junction. What is that? Let me explain it to you in a simple way. Imagine that the current is like a flow of water. If the current comes from the right-hand side as I2, and the current comes from the left-hand side as I1, at the midpoint, they can add up and form a new current as I3. So mathematically, we can say that I1 plus I2 equals I3. And the point that they add up at, we call this a junction. Same thing if the current comes from the lower part as I3, at the junction it can split into I1 to the right and I2 to the left. And mathematically it would be as I3 equals I1 plus I2. Same thing if the current comes from the left, I1. So at the junction, what do we expect? We can expect that it will be split into 2 parts at the junction. The first part is going to be I2 going to the right and I3 going down, and mathematically that would be written as I1 equals I2 plus I3. It's clear that it states only the direction of the current, and this is a part of your calculations. You need to state, at least to propose, a proper direction for the current at one of the junctions so that you can solve the problem properly. An important note, it's okay to make mistakes. If you propose a wrong direction for the current, you will find out in the end that the circuit will fix itself. So it's okay to make a mistake at that part. Now let's understand the second part of Kirchhoff's rules, which is the rule of loop. What does it say? According to Kirchhoff's loop rule, the voltage facilitated to a closed loop equal to the voltage dissipated in the same loop. How is that? Let me show you the circuit. If you look at that circuit, what is the source of voltage in here? This is the battery E1. And we know from our understanding to Ohm's law that the energy facilitated or the voltage facilitated by E1 will be consumed in both resistors R1 and R2. And that can be calculated as that the voltage consumed in R1 would be IR1 and the voltage consumed in R2 would be IR2. So I can say that according to Ohm's law, V equals IR. Or if you apply in that circuit, I can say that E1 equals I1R1 plus I2R2. So what will happen if you have two batteries? Then we need to think differently. I need to know among those two batteries, which one would rule the circuit? What does that mean, the rule? Certainly, just like anything else in the world, the stronger would rule. So imagine that E1 is 9 volt and E2 is 5 volt, then E1 would rule the circuit. How would that reflect on the circuit? That means I'm going to take the current of the stronger one as the default current direction of the circuit. And I know the current comes from the positive side of the circuit. So I will expect that the current comes from the positive side of E1, not from the positive side of E2. This is how you state the direction of the current in a circuit. Now, let's apply Kirchhoff's rule of the loop. Again, the voltage supplied to the batteries by the batteries equal to the voltage consumed in the resistors. But we have two resistors now, two batteries now. Are we supposed to add them up? It depends. How it depends? See, you need to look at the direction of the current that you proposed previously and how it goes through the batteries that you have in the circuit. Remember that you have two batteries and it can be more. If the current that you proposed previously goes through the battery that you have from the negative side to the positive, just like E1 in here, then the battery takes a positive sign. But on the other hand, if the current goes through the battery from the positive side to the negative side, just like E2 in here, then the battery takes the negative side. Remember, this is an important aspect. When you do the circuit, you need to understand how to put the proper sign for the batteries. So in here, the actual voltage supplied to this circuit would be E1 minus E2, because E1, the current goes to the positive, while E2, the current goes to the negative. Now, let's apply it for the whole circuit. Again, the voltage supplied by the battery is equal to the voltage consumed in a resistor. So E1 minus E2 equals I1 R1 plus I1 R2. But what does E1 minus E2 means? It means that here the actual voltage supplied to the battery is not the add them up. It is the subtraction. Why? Because E2, the current of E2, opposes the current of E1. So it takes a part of it. Numerically, imagine that E1 is 9 volt as we said before, while E2 is 5 volt. E2 opposes E1. So what will happen that those two batteries will add up to form only 4 volts. So the actual volt supplied through this circuit is 4, not 9, not 5. Now, let's practice our understanding. In this circuit, we need to calculate the current in each side of the circuit. The first step you do is we need to label the corners of the junction in the circuit. So I'm going to label them as you see in here, A, B, C, D, E, F. Then, let's expect or propose the current. So from the 6 volt, I will expect that the current comes from the positive side as usual. And then, passing by point C, I'm going to call it I1. And then it goes through the resistor is 9 ohm. Continue going till it reaches point B. On the other side, I'm going to propose that the current comes out of the 5 volt, comes up from the positive side, going to the point A. I'm going to call it I2, and then passing through the 6 ohm resistors, and then it will gather up at point B as well. Then finally, I can propose that both currents I1 and I2 will add up at point B, forming I3. That will go through the 10 ohms. And that will continue doing, and then split again at point E, continues, so the loop is closed. Then, according to what we have done now, we can say that the current comes from I1 and I2 add up to form I3. or mathematically I can say that I3 equals I1 plus I2. So we applied now the junction rule, so we're going to keep it in here because we're going to use it later. This circuit has too many loops, or circles. So let's apply Kirchhoff's rule over these loops. I'm going to have two loops in here I'm going to show you. According to the loop rule, the addition of the electromotive force of the voltages equals the addition of the energy consumed in the circuit. So for the first loop, and see how I did it. The first loop, which is BEDCB, BEDCB. What is the energy supplied in that loop? It's only one battery. And the current goes from the negative side to the positive side of the battery, so I'm going to give it a positive side, so it's positive 6. So that's the energy supplied. Now, where the energy consumed would be, the energy consumed would be consumed in the 9 ohms and then 10 ohms. And what are the currents? In the 9 ohms, the current is I1, while in the 10 ohms, the current is I3. So I'm going to say that 6 ohms equals 9 I1 plus 10 I3. Remember, the direction of the current in here follows the direction of the loop that you proposed. If it happens in a different way, we may change that, but not in here. Now, let's see the second loop. The second loop, it goes in the other side, and it is BEFAB. BEFAB. What is the energy in here? It's the 5 volts. And what are the resistors that would consume the energy? That would be the 6 ohms and the 10 ohms. So I can state the same way I have done it before. 5 equals 6I2 plus 10I3. Now let's add up those 3 resistors and see how can we use them, the 3 of them, so that we can find the 3 unknowns I1, I2, and I3. First, I'm going to substitute the first equation in the second one. So it will be finally reaching to the formula 6 equals 19I1 plus 10I2. Then I'm going to take the third equation and I'm going to substitute the junction rule in it. So final formula is going to be 5 equals 16I2 plus 10I1. Now both equations, they are subject of I1 and I2. So I need to solve them spontaneously. I'm going to multiply the first one times 16, and then the second one times negative 10, and then add them up. And the result say that I1 equals 0.23 amps. Now I'm going to use this, that I1 equals 0.23 amps. I'm going to use it in here. So I3 equals 0.40. And finally, I'm going to substitute in the junction rule to reach that I2 equals 0.17 amps. There is an important note I need to add in the end. That if you notice that all the currents are positive, what does that mean? When the currents are positive, that means the proposed direction that you had in the beginning were right. If you had any mistake in proposing those directions, you will find negative sign. And this negative sign doesn't mean you made a mistake. It means only that you have proposed in the opposite directions, and all what you have to do is to reverse the sign of the direction in your circuit, and that's it. Thank you guys. I hope you understand physics. This is Mr. Mahmoud Najm.